Having discussed the three levels of object copying, so now we're almost ready to talk about how you can write complete postconditions. There's just one more background knowledge I would like to discuss with you before we see a concrete and complete example about writing complete postcondition, which is how are contracts checked at the runtime. We talked about it already, actually, in your very first lecture when we talk about how contracts are really checked at the runtime. However, the missing piece in the puzzle really is about how can the postcondition be checked at the runtime. Remember, in the Java example where we try to encode we try to memorize or cache the O balance value by using an explicit temporary variable at the beginning of the implementation. Right? We say O balance, and then once we cache the value of the balance before it's decremented by the withdrawal, we actually save that value in the O balance, and then we use that O balance value in the post condition so that we can compare the pre-state and the post-state value. So if you remember how we did it in the previous lecture in Java manually, so that one should really give you already some insight into how can the post condition be checked under the hood. But now I would like to show you that in Eiffel, since contracts are supported natively, so the way we write the pre-state value is not as inconvenient as what you have to do manually in Java. So that's something I would like to show you, give you intuition. Okay, let me just go over the slides and then show you some illustration, and then I'll show you one example to show you all the possible ways you can write O expression, just enough so you get an idea to be creative later on for your own developments. So all the contracts are specified as Boolean expression, precondition, postcondition, and class invariant. They're all Boolean expressions. So right before you try to execute a feature, let's say before you try to withdraw $10 from this particular ACC. So before that, now we are in the pre-states. What do we do in the pre-states? We have to evaluate the precondition, of course, to make sure the clients fulfill its obligation so that we can go ahead to execute the body of implementation supplied by the supplier. So now this is the most important bullet points for this particular slides. Okay. So now in the pre-states, not only that we have to check for precondition satisfaction, but also we have to be preemptive about what should be needed later on when we want to check the post condition. So here I say cache will memorize values using assignments. So remember when we talk about the previous example, whenever we talk about shallow copy, reference copy, or deep copy, we always talk about the copies in the context of some variable assignments. So the way Eiffel caches value automatically for you, they also do it by assignments. Okay, so we want to cache the values for all expressions in the post condition. But how? Because you may write arbitrary expressions that involve the O keyword in the post condition. So we have to know how exactly we cache them. So starting from here, I will give you different possibility. Let me just enumerate the ones I want to talk about. Don't worry about the details just yet. I will illustrate on the iPad in just a moment. So you may write as part of your post condition, you might say old accounts, assuming that accounts is an array of accounts, right? And now we say old accounts at position I.id. If you write this old expression in your post condition, correspondingly, there will be a variable that's under the hood, behind the scene. So Eiffel does this automatically for you, so you don't have to create this variable. You don't have to, let me emphasize. And the way they cache this particular expression is by saying this is the O keyword, and then this is the expression that should be applicable to the O keyword. So we are going to cache this expression exactly. Okay, so now you can imagine this. Depending on the expression after the O keyword you write, if the expression there involves only reference copy, then in this particular caching assignments, there will be reference copy only. But if somehow you actually put a shallow copy, for example, you might say accounts I.twin. In that case, it will be a shallow copy when you do the assignment for the caching, right? And etc. for the deep copy. That's kind of the intuition. But let me just see all the possibilities here that I enumerate for you. So if you simply write, let's say, a slightly different expression here, I'll explain what the difference is. It's since I just a pair of parentheses. If you do that, is gonna actually cache slightly differently. So here the name of the variable doesn't really matter. It's really up to behind the scene the naming convention by the compiler. So knowing the absolute name is not necessary. I'm just using some intuitive name for you to actually name it. Okay, so you got different possibility over here. I'll explain each one of them in just a moment. Okay, just get the idea. So all these caching process is done in the pre-states, even before you try to change maybe the array or the accounts before the implementation executed. Okay, so now once we have done the caching process, now we execute the implementation of the feature. So now after the feature is executed, so now we are now in the post states. Okay, so now so all we talk about up to here, this is the pre-states, and then we execute the implementation for the feature, and then we go to the post states. Now in the post states, so we have to, number one, we're gonna evaluate invariance. Remember the state diagram that I illustrated to you before in the very first lecture. You have to check the invariance to make sure you're now in a safe state or a valid state for the objects. And so now this is also very important. Think about this bullet points is making this particular bullet point possible. If you didn't do this caching process, it is no way that you can actually evaluate the post condition, especially when those post condition involve some pre-state value which should have been cached. Okay, that's kind of like a textual description. Let me show you one diagram before I show you example. So the way you understand this is like this. Okay, for every feature in the Eiffel, you have a rough structure like this. So you have the precondition over here. So this is the precondition. Okay, let me draw better. Okay, so this is the pre-states, right? And then whatever you want to execute for the implementation due to any updates, and then you only check the post condition when you are in the post states. And the post state is actually after all the relevant attribute values have been modified. But you want to make sure whenever you want to compare the pre-state versus the post-state in the post condition, those pre-state values should have been saved or cached somewhere. So this is the post states over here. So now the question is, if you actually got old followed by some expression. Of course, the expression here can be as complicated as you wish. I will give you an example in just a moment. So here is the flow. Okay, so first of all, when we call the feature F for execution, first of all, we have to check for its precondition to make sure in the pre-states we are actually fulfilling the obligation for the clients. And now we do preemptively because the post condition over here involve this particular expression, because we say all keywords, so that means we actually want to compare the pre-state value for this particular expression. So that means this particular expression over here should be cached in this state, in the pre-state. So it's almost like, for example, you may have some behind-the-scene variable. You say old expression, just invisible, and then it's assigned to whatever expression this is. And as I said before, this expression might involve reference copy, might involve twin, it might involve deep twin, depending on how the user writes it. So whether to make a shallow copy, reference copy, or deep copy is not up to the compiler. It's really up to you as a designer how you write this particular expression. Okay, after caching this particular expression, we're going to actually execute the implementation of F. So now this pink state over here is the post states. So now in the post state, we're going to check the post condition of F, and this F over here, whenever we refer to old expression, whenever you refer to old expression syntactically, it really refers to this particular variable that we use to cache the value in the pre-states. Okay, that's kind of the mental model you want to have in your mind before every time before you try to design your post condition. So having built such mental model about how you can cache the post condition, especially those involve the O expressions. So now we're going to see some concrete example to show you the wide range of O keywords or O expression you can write in the postcondition. So basically, the example you're going to see in a moment is just going to see under a certain context of some feature and under its postcondition, what kind of O expression can you write? There's a wide range of possibilities. I will show you the most common ones just to show you the difference. Of course, later on, when you write your own postcondition, it can be more creative for your need. In order to present the example, let me set up this simple context of two classes. Let's start with this class over here. So we have a class called bank. And then the bank has one collection attributes called accounts. Account is simply of type of an array of accounts. So account is simply just another supplier type over here. So that's why I got a client-supplier relationship over here. And this is a supplier class called accounts. And the account simply has one attribute called ID, and then is of type integer. Okay. And then let's say we talk about any feature over here. It could be a command, it could be a query, doesn't matter. It's just some feature. And the feature has some precondition, has some implementation, and also it has some postcondition over here. So now we are talking about what can we write under the ensure clause in the context of these two classes. Okay? So now in the context of this postcondition over here, what can we refer to? We might refer to current, referring to the current bank objects, right? So it's like a this keyword in Java. In this postcondition here, we can also refer to the accounts, which refers to the array. That's also valid. Or we can say accounts at position I, assuming that I exists, and it's also valid. If I say accounts at position I, it's now referring to that particular account objects. Okay? Or I can even say accounts at position I and then dot ID. So now it's not only that it's navigating to the supplier class account, but also is referring to the ID attributes. So these are the range of expressions that you learned from the previous OO class, how you can navigate the aggregation in your class, right? So these are the possibilities. Now we're going to see how we can combine such expression using the O keyword and to see what the consequence would be in terms of caching those values, those expressions in the pre-states in order for later checking for the postcondition, right? That's something we'd like to see. Okay, just make sure you're comfortable with these two classes and the range of expression that you can write in the context of the bank class. Okay, just make sure you're comfortable before you move on to that to the next slides. So now let's talk about the range of examples I would like to bring to you. Let's say let's assume for the following runtime structure in the pre-states. In the pre-state, we're going to cache the value, right? So now let's assume the following runtime structure. Let's say we have a bank objects. So this is referring to the current, right? So now this is a bank objects, and the bank object refers to accounts, which is of an array of account objects. Position I is pointing to an account objects. And each account object has ID attributes of type integer, for example, 23. Okay, that's the runtime structure we would like to cache to see in the example. So we have very concrete thing to work with. And over here, let me enlarge that a little bit from number 1 to number 7. Basically, we are talking about all the possible O expressions that are legitimate that we can put under the context of the account class and also under the context of some feature ensure clause for the postcondition. Right? So now notice that it's in the context of bank. So what can we write really? From number 1 to number 7, the most important preprocessing task you have to perform is about to what extent does the O keyword apply in the expression. So you have to see what's the coverage for the O keyword. So let's just go one by one to get some intuition. So let me just highlight it. So let's say for the first one over here, you can think about the O keyword is over here, and it applies to the shortest possible unbreakable text for your program. Okay, so now you can see I go for accounts, and then I see some indexing notation. The square brackets is unbreakable. I cannot simply just break it into the left and the right. And then I'll go ahead to the I and go ahead to the closing brackets that's also unbreakable. And then I will see the dot over here that's also unbreakable. I cannot simply divide this expression into the left and the right. It wouldn't make sense. It has to come together. Okay, so now after this kind of short analysis, what I'm going to have is, so this entire expression of type integer, right? So now you can analyze type quickly. Again, this part over here is an array of accounts. And after applying the indexing notation, it's going to be of type accounts. And then the whole thing, the ID, is just going to be integer, right? So let me just, the whole thing, after applying the ID, it's just going to be of type integer. So now when you actually write number 1 as the old expression in the context of postcondition, it's actually going to cache just a single integer value at the, in the pre-states. We're going to see exactly how that's going to be achieved in just a moment. Okay, so now we're just doing pre-processing job just to identify the coverage of the old keyword for every example. So what about the second one? So whatever I highlight in orange will be the coverage. For the second one here, let's do again still do some pre-processing analysis. You can see there is this particular parenthesis. Parenthesis is one way to break the shortest unbreakable sequence so far. So now, once you get a parenthesis, that means you can actually break it over here. So now, so that means the old keyword is over here. So now the shortest unbreakable should be only up to, but excluding the closing parenthesis. Okay, so that one there is only to cache the accounts objects. Okay, you can see this particular expression here is of type accounts. So that means for, if you write the expression in the form of number 2, that one is only going to cache an account objects in the pre-states. Okay, so now number 3 is interesting. If you contrast number 3, okay, first of all, what will be the shortest unbreakable? Again, we got the closing parenthesis that suggests we should break it there. Okay, so now the shortest one should be like this. So now notice that between number 2 and number 3, we're going to visualize that in a moment. But number 2 and number 3, the difference is for number 3, you say whatever the account object is, dot twin. We are taking a shallow copy of that account objects. So now this is going to affect the way we do the caching in the pre-states. So that means in this particular case, in the pre-states, we're going to cache a reference copy of this particular account objects. But for number 3 over here, in the pre-states, we're going to cache a shallow copy of the account objects. Okay, so that's why I said previously, I remarked by saying it is not the Eiffel compiler which decides whether you should do a reference copy, shallow copy, or deep copy. You as the designer, the way you write your postcondition will determine how the Eiffel compiler is going to cache your postcondition. In this case, as you can see here, you say accounts I without any mentioning any twin or deep twin. So that means it's going to cache a reference copy. On the other hand, over here, because you mentioned that twin, so you're indicating to the compiler that you want to make a shallow copy of this particular expression in the pre-state to cache it. Okay, let's go on to see more example. Let's take a look at number 4. Again, we got parentheses over here. So now hopefully you feel a little bit more comfortable about doing this. So what will be the coverage for the old keyword? So that's the end of the parentheses. So it should be just accounts. So now what's the type of the value that we're going to cache? Is it going to be an array of accounts? Is it going to be an account? Or is it going to be an integer? So that's the type you have to know. Oh, by the way, in the previous case for number 3, even though we're making a shallow copy, but the type of object that we want to cache will still be an account. Just a shallow copy of the account. Okay, and let me just write this type over here. So I will indicate for every expression what's the type that you want to cache. And for number 4 over here, so now we know that it only covers just the accounts variable over here. So that means it's going to cache just an array of accounts. Reference copy, more specifically, because you don't really mention any twin or deep twin. So that would just be an array of accounts. What about number 5? So hopefully you're getting more and more comfortable about doing this. So now for number 5, again, we got parentheses over here to break it. So now it would be just accounts.twin. And then, so this one here is going to be of going to cache an array of accounts still. It's just that we're going to make a shallow copy of that. So the type of value would just be the same to be cached. So an array of accounts. Okay, let's do one more. So what about this one here? This one, number 6. Number 6, let me remind you about what current really means. Remember, we are talking all the post condition we are talking about right now is under the context of the insure clause. That's in the context of the bank clause. So whenever you say current, it's like you said this in Java, the current class or the current object. So when you say current, it's really the referring to the bank objects. That's in the context. Okay, let's go back here and continue. So now, again, we got parentheses, so that means it will cover just the current. So now if that's cover just the current, it's going to be of type bank, a reference copy of the bank. So that will be just the bank. Okay, I'm sure you can do number 7. Let's complete it. So now what about number 7? Again, we got the parentheses to break the shortest sequence of the coverage. So now it should be just current.twin, a shallow copy of the current bank objects. Of course, you can imagine we can also write another alternative, which will say old current.deepTwin, parenthesized. That's going to be the same type, but it's a deep copy of the current bank. So now this is also going to cache a value of type bank. Okay, so we have done the very critical pre-processing task about how we can cache the value. Let's now visualize how the caching is going to be done. So now let's imagine we are now at the timing of after checking the precondition of the client's obligation. Let's say all of them are satisfied. And now we are right at this point over here, right before we try to execute the implementation of the feature. And now the compiler for Eiffel will automatically, without your consciousness, basically, they will simply do it for you. They will simply look at the insure clause over here to find out all the old expressions. So now we're exploring all the possibilities. So now what's going to happen in over here? So now we're going to cache the old expressions. Let's see how we can do it. Okay, let's go one by one. Let's now start with number 1, right? You already know about the preprocessing process, and so now let's see how we can do it. So now for number 1, it's very easy. We're only trying to cache an integer. So now number 1 over here in the pre-states is just going to store some temporary variable. And the temporary variable is going to be something that's according to the naming convention of the compiler. You don't need to know the absolute name for that variable. I think so I'll just, for easiness of comprehension, I'll just use some convention here. I'll simply collapse the entire expression into a single word, so you will see. So behind the scene, the Eiffel is going to create in the following process. It's going to say old accounts ACCS at position I ID. So this is a temporary variable that's created behind the scene. They're going to cache in this way. In the pre-states, they're going to say this variable over here is assigned to basically this particular expression. So they're going to say accounts I.id, right? So this is the accounts, and then go to I, so that's referring to this account objects. The ID is going to be 23. So what the consequence of this is, it's going to create this variable over here and simply store 23. Okay, it's a primitive type, so I don't really draw any arrow here for references. So now this very first case really corresponds to an earlier example that we did. I would like you to do a very quick connection over here. Okay, if you go back to lecture 1 that we covered previously, and then for lecture 1, go to where we talk about how you can support DBC in Java. Okay, especially when we talk about how you can encode manually about the post condition. And the example there we talk about is about the withdrawal. And remember, the post condition there is simply balance equals old balance minus the amount. So now old balance is exactly the value we want to cache, just like we are trying to catch the ID over here. So I want you to review that particular Java code encoding versus this. So now it again reaffirms Eiffel being a design language really make it much easier for you to write the contracts and check them at the runtime automatically. On the other hand, Java, whereas being a very good implementation language, they didn't make it very convenient for you by supporting contracts. You had to manually encode it and think about how they get executed, right? So now that's the difference I would like to highlight. Since this remark is so important, I would like to make it more precise for you. Let's now revisit version 5 of your Java account class that we did in the very first lecture about DBC. So we have version number 5 for the account. And then remember, in order to check the post condition over here, we want to say this.balance. So we're talking about the withdrawal method. This is the post state value over here. And then we want to say old balance over here. But in order to do it, it's not that direct in Java. We have to say cache in the pre-state. You can see this is right before we try to execute the method implementation, which is to actually decrement the balance amount for the withdrawal. So this is actually the pre-states. So we have to manually encode this variable over here in the pre-state so that when it gets updated into the post-states, we can still see the difference. So now pre-state over here, let me just write it down. Okay, you can see the whole process is really manual, so which is not going to scale up to larger example, especially when you have sophisticated expressions for post condition when necessary. In that case, you will need to manually cache many pre-state variables like this, which is not going to work. So let's say, now the question is, how does the corresponding Eiffel design, so Eiffel is a design language which makes it convenient for you to actually do such constructs automatically. So with automatic caching of the pre-state value. So now let me just sketch very quickly. In Java, in Eiffel, what you will do is like this. So with your withdrawal method, assuming that it's not in the context of your account class. Of course, let's say we got amount over here, let's just say A. And then you have your precondition, you have your implementation, and now I simply say ensure over here, ensure, and then what about the ensure? So here we want to relate between the pre-state and the post-states. So what we would say is we can say current, so you can think about the current over here correspond to the this over here. Current dot balance, so this is referring to the post-states, right? It's exactly correspond to this expression here. Equals, so now, rather than referring to some explicit caching variable, so what we can do instead as a developer is just to use the old expression as long as we know what we are doing. So let me use a different color here. And you will simply refer to the pre-states using the old keyword. So you would say old, and then balance. Okay, so that's how you can refer to it in the Eiffel. So now, when you actually try to execute this particular Eiffel design code at the runtime, this is what's going to happen. So now over here, right before, let's say after checking the precondition, now in the pre-states over here, the compiler will simply try to see your post condition. It currently is simply just this particular equality. And then you will see that you're using the old keyword, and what does it really cover as the exercise we did. So old is going to cover just the balance over here. So now what we will do, what the compiler will do is to simply cache this particular variable in the pre-states. So this will simply correspond to, you can see this part of the old expression implicitly is simply Eiffel compiler, and you wouldn't see that just behind the scene. It will simply have its own naming convention. Maybe old balance over here is simply assigned to whatever expression that's covered, just balance in the pre-states. So now this is now representing the caching version of the pre-states. So later on, once we execute the implementation for this particular feature for the withdrawal, and then when we try to evaluate this post condition here, in order to evaluate this particular old expression over here, what we will do is we're simply just going to refer to the value for O balance. Okay, that's what's going to happen behind the scene. So that's why I kind of show you in the very first lecture how you can encode such postcondition in Java manually. So now when we get to the point that you're using it to specify natively in Eiffel, all you have to understand is what's going to happen behind the scene. And once you understand what's happening behind the scene, you can just write your O expression appropriately to really get what you really want to specify the postcondition.